The heart of the cable is always the conductor. All metallic wire and cable has a conductor, and all the other components of a cable support the function of the conductor. Conductors conduct electricity, meaning that the electrons flow down the metal. Most of these conductors are going to be metallic or a composite of metallic materials. Copper-clad steel, for example, would be used on RF cables, tinned copper on cables that might be exposed to wet locations, and then solid bare copper as shown in my example in my hand. Amperage is actually the killer in the electrical circuit. It only takes as little as 200 milliamps to kill an adult human being. So you have to be very careful when you're dealing with current. Direct current, or DC, it only goes in one direction. Alternating current, which is most commonly used in households, is AC. That cycles back and forth in two different directions. In the Ohm's law, abbreviation for current is an uppercase I. The next type of conductor is stranded conductors. These are wires with multiple solid metallic strands cabled into one conductor. These are a poor choice for higher frequencies, and they usually have a larger diameter than solid wires because of the air spaces that are introduced. Some of their benefits, though, is they have a high flex life and they're very resistant to breakage. In some cases, you can actually put the right stranding in here to get 5 or 10 million cycles before breakage. Here's a description of impedance, which is the combination of the resistances. You have your direct current resistance of the copper wire, you have capacitive reactance, inductive reactance, and this is measured in ohms and abbreviated by Z. And to give you a little middle school math lesson, if you remember the Pythagorean theorem, this graph on the side shows you have your R for your DCR, your XC for your capacitive reactance, and then your inductive reactance actually brings that back down a little, and there's your impedance at Z. With fiber cable, you have to be even more careful with installation issues. Fiber cable will begin to lose modes. The light rays will actually escape the cable as it starts to bend to a certain point, and then your actual glass will crack and break. And this introduces insertion loss issues, and you could lose your signal entirely.